students, welcome back to my channel. We are doing a series on ICSE 10 biology chapters. We are in absorption by roots chapter. This is video number 3, experiments on osmosis. Before we look into the definition or probably the experiment itself, we should understand certain concepts pretty clearly, and they are dilute solution and concentrated solution. What is meant by dilute solution? What is meant by concentrated solution? Please keep in mind that whenever we say something is dilute or something is concentrated, it is always with respect to some other solution. So we need to take two solutions for us. We are taking one solution here in a beaker and another solution, that is, we're just taking water as of now and adding some solute to it to make it solution. So if you're not clear with solute, solvent, solution, those concepts, please watch my previous video. Right now, I have two beakers with same amount of water almost. Let's say before I add water, let's say I add 5 gram of sugar to this solution and 10 gram of sugar to the second solution. Once I add that, I add water and make it up to 100 mark. Alright? Okay. Now, in which case is the solute hydrogen here? Yes. So, wherever the solute is high, we call such solutions as concentrated solutions. With respect to the other one, with respect to this one, where solute amount is less, we call that as dilute solution. I hope that is clear. Now read the definition of osmosis. Osmosis is movement of water from where the concentration of water is high, okay, to where concentration of water is low. That's why I have marked this word there. Please read the statement again. Movement of water from a region of their higher concentration. There means what? Water's high concentration to where water is less or low concentration of water. What's the other way of expressing it? High concentration of water in this case will be where solute is high over here. That means water is less here. Yeah? Solute is less here. Therefore, water amount is more here. So, whenever I say it's a dilute solution, that means water concentration is high, solute concentration is low. That you should be very clear. Otherwise, you will go wrong and you lose that 1 mark of definition of osmosis. Now, let's understand what is osmosis through a simple way. Okay. Now, let's say I have a semi-permeable membrane. Semi-permeable membrane means it permeability or the ability to for things to pass through it is only partial. Okay. So this is a membrane which allows only certain things to pass through. What does it allow it to pass through? It allows water to pass through. Such membranes are called as semi-permeable membrane. Okay. Now, if I'm separating two liquids, all right, by using a semi-permeable membrane. So, there is a liquid here, liquid number 1 is here and liquid number 2 is here. Both of them are separated by semi-permeable membrane, let's say. What happens? Water starts moving. How does water start moving? Water starts moving from where water is more to where water is less. Now, if I were to separate these two, this is my solution number 1, let's say 5 gram per whatever amount of water, and this one 10 gram, this one. These are my two liquids, let's say. Alright. If I'm separating these two, from where to where water will move, can you think of this? I'm telling again, water moves from where water is more to where water is less. In these two beakers, where is water more? Here, isn't it? Wherever dilute solution is there, water is more. So, water starts moving from dilute solution to concentrated solution. Yeah? So, that's the definition of osmosis. Now, knowing that or keeping that in mind, let's understand the experiment. Okay, I have here one beaker. In that, plain water is there. That means it's a dilute solution, isn't it? Whenever I take a dilute solution, the amount of water in it is more. That's why we call that as dilute solution. I have that. All right. Now, in a funnel, this is a funnel. All right. The funnel looks like this. Initially, in a funnel, I cover this side, let's say, for rest of now. And then I fill some concentrated solution in this. After filling, I cover the mouth of the funnel using a semi-permeable membrane. Then I completely tilt it. Okay, this part will come down and I'm just inserting that funnel which is having the concentrated solution into the beaker of water. And I allow it to stay using this stand. I'm tying it up and allowing it to stay. Initially, as I kept it itself, I will mark till where do I have the concentrated solutions level. Alright. Now, here water is there. Here also some solution is there, which is concentrated, separated by a semi-permeable membrane. Okay, because I've covered the semi-permeable, the mouth of the funnel using a semi-permeable membrane. Okay, the semi-permeable membrane's name is cellophane paper. Okay, then I leave it. What happens? Water starts moving because it has to do osmosis, right? So from where to where water will move? Water moves from where water is more. What's the other word for that? Dilute solution or their higher concentration. There means water's higher concentration to where water is less. So the water starts moving inside to the funnel. So what happens? Overall, the water level in this will increase. Okay, slowly it will start increasing. This shows that osmosis has occurred. Alright. Now the same way there is one more way there is a variation of this. Instead of the cellophane paper, we can use a rubber sheet. What will happen if we use rubber sheet? Rubber sheet is a proper sheet. It does not allow anything to pass through. It's an impermeable sheet. So no change in water level will occur. Okay. Another is muslin cloth. Muslin cloth is like your handkerchief. Imagine handkerchief. Will it allow this water to stay inside? No, nothing. It cannot stop anything. Okay, so it's a freely permeable membrane. What will happen? Completely this water will come off from here. This concentrated solution fully it will come off because there is no osmosis happening. It's not a semi-permeable membrane. Fully this water will come off. That's the second variation to this experiment. Other than that, in your textbook, there is one more called as whisking bag. What is that? Let's learn that as well. So here, there also they have given you a beaker. Same way. In the beaker, they have kept water. Alright. Now, instead of the funnel and everything, they have kept a kind of bag kind of thing. That bag itself is a semi-permeable membrane. Okay, that bag is a semi-permeable membrane, whisking bag it's called. Inside that they have kept sugar solution. So isn't it the same thing as previous one? It's almost the same thing, isn't it? Instead of only one side having the semi-permeable membrane over here, the entire bag itself is a semi-permeable membrane. So obviously, it will start increasing in volume. The amount of water inside will increase. So this will start swelling up. Okay, that's the only difference. Now, these are the two experiments regarding osmosis. Now, one more thing concept is osmotic pressure. What do you mean by osmotic pressure? Osmotic pressure is, let's say I have one solution inside. Okay, it will pull water in, correct? It will pull water in because it's a higher concentrated solution. Yeah, it's a higher concentrated solution compared to water. So it will pull water in like so. Alright, it has the ability to pull water in. That ability to pull water in is called as osmotic pressure. In other words, if I keep on increasing this sugar solution, which is pulling sugar solution's concentration, instead of 5 gram, if I keep 15 gram solute or 25 gram solute, that means the sugar solution's concentration I have increased. Right? So that means more is the ability to pull normal water in, isn't it? That ability to pull water towards it, For any solution, that ability is there. That ability is called as osmotic pressure. We'll define it from the textbook, your page number 42 for my textbook. It says that osmotic pressure of a solution is a measure of its tendency to take in water by osmosis. I hope it is clear. If you have any doubts, please ask me through the chat box below. Thank you. We will continue in the next video. We will understand the rest of the chapter.